what I have here are two standard deviation problems. These numbers in the data sets for these standard deviation problems, these numbers were hand-picked. I made up these data sets. This is from a previous semester. And I want you to notice some things about the data sets. In both of these data sets, example 1 and example 2, the mean score is 50. The score right in the middle. From 50, I moved out with more data items to where it was a perfectly symmetrical data set. Started with 50. I moved out 10 points. I got 40 and 60. I moved out another 10 points, 30 and 70. I moved out another 5 points, 25 and 75. I went 5 more, 20 and 80. And then I went 15, 5 and 95. So they're perfectly balanced data set. You're typically not going to find that in the real world. Example number 2, also perfectly balanced. I started with 50. Oh, there were 3 scores that were 50. I went down by 2, I went up by 2. Then I went down by 5 and up by 5. Then I went down by 3 and up by 3. Then I went down by 2 and up by 2. The standard deviation is a measure of how spread out the scores are from the mean. It's an average of how spread out the scores are. Example 1 and example 2, which one is more spread out? That's a silly question. You know the answer, right? Example 1 is more spread out than example 2. Example 1 is going to have a bigger standard deviation. I'm going to start on a clean sheet of paper and work this out for you so you can see how we calculate standard deviations. I'll put my page sideways. For your notes page, I will write here at the top, they take up about a whole page. Example 1, find the standard deviation. I'm going to write my set of numbers a little bit lower than that on this page from a previous semester. Here's my set of numbers. All this writing I did at the top, that was interpreting my answer. What does it mean once I have the final answer? So I want to leave a little space there to come back and put in my interpretation. I'm going to build it from the middle. The mean is 50. Then I had a score that was 10 points higher. I had a score that was 10 points lower. I had a 70, 10 points higher than 60. I had a 30, 10 points lower than 40. Then there's a 75. There was a 25, 80, 20, 95, and 5. This finding the standard deviation is a 6-step process. step number 1 is that you find the mean of the data items. All right, step 1, find the mean. This is what, in a statistics class, they'll call X with a line on top. It's not called X with a line on top. It's written X with a line on top. We read it X bar. X bar stands for the mean of a data set. To find the mean, you add up all the numbers and divide by the number of scores. You might look at this data set, and since it's perfectly symmetrical, perfectly balanced around the 50, the mean is going to be 50. I wrote divided by 11. Are there 11 scores? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 11 scores. If you add up the numbers in the numerator, you will get 550. Divided by 11, the mean is 50. Step number 1, find the mean. On the homework problems, they have you finding the mean on some of these problems and then doing step 2. Step 2, for each score, we calculate the score minus the mean. Step 2, I'm going to write score minus mean. I'll put that in parentheses just because I have step 2, and then that's how you do step 2. I'm going to start with the 5. 5 minus 50 is negative 45. Then 20 minus 50 is negative 30. 25 minus 50 is negative 25. 30 minus 50 is negative 20. 40 minus 50 is negative 10. 50 minus 50 is 0. 60 minus 50 is 10. 70 minus 50 is 20. I have to go to a new column to finish it. 75 minus 50 is negative 25. 80 minus, oh, that's positive. Thank you for that. 80 minus 50 is 30. 95 minus 50 is 45. Now the comment I'm going to make next is not a part of the calculation of the standard deviation, but it is a way you can kind of check your work up to this point. If you add these numbers that you've just gotten from the subtraction, what are you going to get? 0. There are some questions on the homework about that. Find the deviation from the mean, and what is the sum? And the sum is 0. A few years ago, I had a student who wrote me an email, and she said, well, I have a mistake in there. I don't know what it is, but I know there's a mistake because I'm not getting 0. And I looked at the work and I looked at the problem, and it was one of these problems where you got a lot of decimal digits in the decimal part, and because of rounding, She wasn't getting 0, but she was getting something really close to 0, like 0.035. And she was like, I must have made a mistake. I'm not getting 0. So, oh no, you're fine. If you have some rounding like that, you might not get exactly 0 because it's called round off error. And it happens when you've rounded. Step number 3 is to take the numbers from step 2 and square them. So I will write step 3. I will do score minus the mean, that's in parentheses, a square on the outside. So negative 45, the negative is in parentheses, squared. Now let me make a little comment about this. I'm going to put this on a separate little piece of paper to comment. Negative 45 in parentheses squared is not the same as negative 45 not in parentheses squared. I'll have to confess, this is something I didn't realize till I was in grad school going for my master's degree in math. I'm like, what? That never presented a problem to me before, but this is true. Negative 45 in parentheses squared is negative 45 times negative 45. Is that going to be positive or negative? That's positive. That is 2025. Without the parentheses, it's this. It's like negative 1 times 45 squared. And the negative does not get the square. So that's negative 1 times 45 times 45. And this is negative 2025. Now, I mentioned this to you, because calculators are all different. And the one that we're using knows this little detail. It's programmed for this. So if I take my calculator and I just put in negative 45 without parentheses and square it, I'm going to get negative 2025. On these problems, if you put this in your calculator, you're going to have to put the negative 45 in parentheses so that it will square the negative sign, and it's 2025. Or you might look at it like this. I know this is a negative times a negative, and it's going to be positive. 2025. All the numbers you get on step 3 should be positive. So I got negative 45 squared. The next one is negative 30 squared. Then I have negative 25 squared. Negative 20 squared. Negative 10 squared. 0 squared. Well, that one's easy. That's 0. Negative 10 squared will be 100. Negative 20 squared is going to be the same as 20 times 20. That's 400. 25, or negative 25 squared will be the same as positive 25 squared, 625. And negative 30 squared is negative 30 times negative 30 is 900. Now, that's only a part of the numbers. I still have to do those positive ones I've gotten. 10 squared is 100. 20 squared is 400. 25 squared is 625. 30 squared is 900. And 45 squared is 2025. I'm going to try to squeeze in the last few steps on this page. Step 4 is that you add the numbers from step 3. Step 4, I will just write add step 3 numbers. Take out my calculator and add up all those numbers. 2025 plus 900 plus 625 plus 400 plus 100. Now, because this data set is perfectly balanced, I got the same numbers repeated. So I'm just going to add up one column and then multiply that by 2. I get 8,100 for the sum. Step number 5 is the one that we kind of get the most questions from. It's a division. We're doing an average of how far the scores are from the mean. So I need to divide. But we divide by 1 less than the number of scores. Divide by 1 less than the number of scores. I have 11 scores. We're going to divide by 10. So 8100 divided by 10 is 810. If you take a statistics class, that number is called the variance. The number I got in step 4 is called the sum of squares. Step 6, you do the square root of step 5. I'll just write square root step 5. This will be the square root of 810. In my calculator, second square root 810. Your calculator will open parentheses for you when you press square root. Go ahead and close it where it should be closed. 28.46049,894. I'll write 28.46 for the standard deviation. I want to do a little interpretation of what this means. I will go back to the top where I have all the numbers written. And the mean is 50. This is an average of how spread out the scores are from the mean. So with the mean of 50, I want to start at 50 and add the standard deviation. 50, I'll do 28.5 just because it'll be easier to add. 50 plus 28.5. I've rounded the standard deviation to 1 decimal place. That's going to give me 78.5. A score of 78.5. There is no score that is exactly that. But if there were, it's right there between 75 and 80. If I take 50 and subtract the standard deviation, 50 minus 28.5 is 21.5. So coming the other way, that puts me between 20 and 25. 50 minus 28.5 is 21.5. If I add it again and subtract it again, let's do that. 78.5 plus 28.5. $78.5 plus 28.5 is 107. Now that puts me higher than my highest data point. And if I subtract again, that's going to put me lower than my lowest data point. 21.5 minus 28.5 is going to give me -7. Now this is a small data set. For a real large data set, say the heights of 10,000 college students, you're not going to find that 2 standard deviations will encompass the whole data set. This is being a small data set, that's what happened here. As I look at this, there are 7 of my scores within 1 standard deviation of the mean. 7, there were 11 scores. 7 divided by 11 is about 63.6%. Now for a really, really large data set, that's about what it is. Yeah. Let me try to answer that question. What do these numbers mean? Let me come back to that. On this problem, all of my scores are within 2 standard deviations of the mean. Okay, so what do these numbers mean? Let's go to a new page for that. Here's my data set, 5, 20, 25, 30, 40, 50, 60, 70, 75, 80, 95. The standard deviation is 28.46. That means that that's an average of how far apart the scores are from the mean. If I look at how far is 40 from 50? 10. How about 30 from 50? That's 10. That's 20. This is 25. This is 30. This is 45. On the other side, we have 10, 20, 25, 30, and 45. It's an average of sorts of those numbers. That's what it means. Now, I'm using that kind of loosely Because you might be looking at that and thinking, I'm not getting that for the average. There's some adjustments in this formula. Yeah.
So on the test, we're gonna need to not only find the standard deviation, but find like the other points as well after we find the standard deviation.
There are some that they will ask you to find some of those intermediate points.